has alluded to, a benchmark is a point of reference from which we can make measurements, something that can serve as a standard to judge other things of the same kind. Now in IT, it's often used to refer to a standardized test set, to a model of testing things, comparing apples to apples, software programs, databases, computers, and so on. Now benchmarks are, as Becker also alluded to, are key instruments for improvement, key instruments for markets, innovation, comparing, by making things measurable and enable people to find out how they can measure aspects of their products, of their designs, and find out the difference between, measure the difference between bad and good and better. Now the problem is, in preservation and curation, in digital preservation and curation, there is an utter, complete void of benchmarks. We don't have benchmarks. We don't have benchmark data. We really have nothing that would qualify as that under any scrutiny. So now preservation and curation, as you'll know, is aimed at understanding how we can, how digital information artifacts can be sustained authentically and usably across time and space, across changing socio-technical environments. And it's really so that future clients can use and access information in those objects. Now, the challenges that have to be overcome range from actually keeping the bits that are in those files through developing tools to connect objects and files that come from one computing ecosystem of a particular time to a computing system of a different time, to the organizations and the sustainability and the processes of the organizations, so that they can actually store those digital artifacts across the environments, across the ecosystem, and make sure they arrive safely. Now, the things that we need to benchmark, things that we need to measure, are on these different levels, on the levels of the objects, the actual outcomes of preservation in the end, of the levels of the tools that we apply to process them, to keep them, to change them, to transport them, but also on the organizations and their processes. Now, I want to provide quickly a little background on the last of those European research projects, the SCAPE project, and it provides much of the context and motivation of the perspective from which the challenges that I want to address here and want to emphasize here are discovered. And I want to outline shortly three challenges that are particularly playing a strong role in holding back applied research and also the improvement of practice in the field for the last decade, basically, and which are the focus of the Austrian research project that I started in Vienna and I've brought here now a short while ago. Now I want to show you quickly a short key idea between the way we tackle one of those problems, and that is basically big data generation, but so far we only do data generation, not big data generation. And highlight the other two challenges for which I think this faculty is actually a fantastic place to make a significant contribution to the field. Now, I want to very shortly remind us of one fundamental nature of digital, which we all basically know, but it's very easy to forget about it in a way. So, and it's really this split nature that digital objects are a bit like Schrödinger's cat in the box. Actually, they are the box and the cat. And it's very easy to forget that. We say, take a look at the letter I sent you in this email. But we didn't really send a letter. We sent some code that was representative of the state of a performance of an application in a computing environment at the time of us pushing a certain button, which led to this code being generated. Now, before we really open the file, open the box, we have no idea about the letter. There's no letter. It's only when we put this binary code into action and perform it that a letter appears in front of our eyes, or something that we perceive as a letter in our brain ultimately. We don't really open it. We start a computational process, right? A performance. So without that process, that might be an authentic bit stream, but it's not an accessible digital object as we actually think about it. Right? And it's this inherent problem that is bothering us quite a bit. So what is the perspective that I meant here? It provides much of the motivation for my work. It's basically the perspective of organizations that are responsible for digital content, for stewarding over time, the digital content that they are responsible for. So basically we have certain people in an organization. There is content, digital objects, which are managed through information systems using a set of information systems having more or less well-defined goals and policies. Now, in the end, there is a whole set of different technical solution components that such an organization can employ and put to use in order to act on those, in order to produce format profiles to identify what is actually the file format, to identify more specific characteristics, to extract metadata, to perform migration actions, to set up all the emulators, to connect a legacy file to a new computing ecosystem, but also to conduct quality assurance and measure the verisimilitude of those digital object performances over time to verify if what we're looking at in this different ecosystem is actually something that we think is an authentic object, an authentic letter. Right? So in order to decide on all those different tools and methods and techniques that are there, and each of them has a very specific strengths and weaknesses, and they're all software, they all have bugs and errors and instabilities. We need good mechanisms and tools and methods for decision support, for deciding what are the right things to do, for measuring, and for making this manageable in an organization. This is much of what I did in my PhD, looking at preservation planning, how can we evaluate, systematically verify, and test, and produced a few methods and tools here, which are now one of the focus areas of the SCAPE project, which is now in its final year, and has 12 months to go, actually, a few days ago. So the thing is, those things do decision making. They basically perform business intelligence, discovering what is the content of an organization, how does this relate to the environment that is constantly changing, is it still aligned, and so on. And then there's a community environment, especially the preservation community is very active and very eager to share information across organizations, and is increasingly also using information sources that are outside the core domain of preservation, actually, and come from other areas of IT or bioscience and all other things. Now the problem is, if you want to make this scale on terabytes and petabytes of data in multitudes of organizations, those things need to work together. And that was one of the things that really held back the scalability of all these things in reality, that they didn't work together. The languages used, the vocabularies, it's a big mess. And so one of the things we did this year, and which we just presented at the preservation conference in Lisbon last month, is introducing a model, a simple, core, extensible model for decision makers to specify their objectives, specify their goals and policies in a way so that the decision-making tools can actually understand the vocabulary in it, can collect the appropriate measures and align this. Now, it's in this environment really that a few challenges really hold back much of that, and have been holding back for a lot. And the one is that there is no reliable and meaningful benchmark data set that you can use to actually test those solution components in a way that is in any way comparable to a scientific approach. There is no good models that really facilitate the assessment and improvement of what organizations do and how well they do it. There are certain reference models, but they don't necessarily help in assessing and improving the goals of an organization. And then all of these things are ex post. There's very little applied knowledge and very little substantial knowledge on how we can actually design this longevity into an information system before we build it. So those three challenges motivated the project Benchmark EP, just very shortly, which is funded by the Viennese Science Fund with 2 key research partners, and now third at the University of Toronto. The other 2 are the Vienna University of Technology's Digital Preservation and Software Engineering groups, and the Information Systems group at INESC in Lisbon. And we have 3 application partners, 2 of which are here. The Austrian State Archive as an organization with a legal mandate, and the United Nations Food and Agriculture Organization, which is a very interesting, complex organization with a mission to sustain knowledge and spread knowledge over the long term to further the nutritional well-being of the planet's population. So clearly that knowledge nowadays is very much collected digitally. So what is the problem really? So one of the first challenges really is that the preservation and curation communities are very busy organizing hackathons and developing tools to do migration, to do characterization, to do file format identification. But those tools are sometimes correct, they're sometimes not correct, they're sometimes reliable, and sometimes not. But there's no easy way of telling, and there's no systematic way of actually verifying them. There's lots of new tools produced, new versions of tools produced, and it's said that they're better designed, that they're more powerful, but there is no evidence on the actual improvement in any case that can be tied to return on investment, to correctness, to actually performance that is measurable. Now, other fields like information retrieval have for a long time been able to build on strong metrics and benchmark data to actually foster competition and systematic improvement to the point where they have validated knowledge base on the metrics that you can use to measure it, but also on the limits of those metrics, because obviously they can only tell us so much. So the problem was mostly that what was done is data were collected from libraries, archives, museums, data centers, and then the effort was made to annotate the data, to label the data. Now, then it was discovered that policies cannot be violated, that prohibit this data from being shared, that copyright doesn't allow that, but also the technical issue of this black box and Schrödinger's cat in the box. You can generate an annotated data set, but you don't know if what is inside is correct. So the point is that it's a little bit like if you're trying to take photographs with very bad eyesight. You don't really know what's happening in front of you. And now preservation is not necessarily the first field that has this problem. Now, how have others dealt with this? So one interesting case is astronomy, actually. When you build large telescopes, you can't really shoot them up into the sky like the Hubble. It's a little too big. So you have to stay on ground. But then what you see is a bit like the sky in Toronto on an evening. It's very blurry because the atmosphere is just between you and what you actually want to see. It's very blurred. Now, what some very smart astronomers came up with about 20 years ago was adaptive optics. What they actually did was basically switch on an artificial star in the outer atmosphere in 60 kilometers height by illuminating gas with a laser, basically switching on a light bulb so they know where it is, how bright it is, what the spectrum of that color is. And you look at that light bulb, and it doesn't look like how it's supposed to look. Now, based on that difference between how it's supposed to look and how it is, you can actually correct the optics that you see of the other stars. And this is actually a weak case, but there is vast improvement done with these methods. Now, it shouldn't be possible to basically switch on the light inside the box, inside the file. That's the basic idea here. So the actual implementation behind that is a little more complex. Basically, we're missing the ground truth to verify whether a measure that we take out of a certain object is correct. The basic idea is very simple at this point. We just don't want to start with the object, we just want to start with what we define as the truth. We start with a model of the truth, which becomes the ground truth, and we generate the objects from that truth. So at this point, it looks very simple. If you go a little more into the details, it becomes a rather complicated, complex application of model-driven engineering, code generation, and controlled experimentation to the problem of coming from the conceptual model of what is a letter to a representation in different environments, in different software environments that have different feature sets, to the actual software code, the data generator that is generated from the models, which can then be run in a real environment. Basically, what is done is a simulation of the object creation process using generated code. So the nice thing about that is, just as Pericles said, it has the same benefits. It's completely unrestricted. There is no issue about copyright or privacy violation. We have full control over what we generate. We can control the variance on each of the different levels of the conceptual level, but also on the technical level, and we can generate as many objects as we want. And we don't have to send around the objects, we can just send around the generation framework. The feature distribution that we start with is based on large-scale analysis of big data sets, which we cannot take outside, but from which we get statistics. Just like the same case, we can get the data set of the Danish Web Archive, for example. So we have, in the very first iteration, we have 500 million files, which is really just, I think, 3% of that Web Archive, but it's a nice number to start with. So once we have that, we can really measure the tools, and we can verify whether the tools that the organizations use are actually correct or not, which is a very nice start. But there is more than that, obviously. Those tools are used in business processes, they are used by different people having different goals, different evaluations, and so on. And organizations now are really struggling to assess and improve, and also to communicate to upper levels of management, we need so and so much money to improve what we do right now because of X. And the real reason for that is really a gap between preservation and curation and information systems. The domain knowledge that exists in preservation and curation is really not very well connected and well anchored in information systems frameworks, in IT governance, in information systems architecture, and so on, in ISD design principles. But the information systems frameworks that do governance and measurement and management, they don't address longevity as a concern. They address security pretty well, but not longevity. So essentially, So what we did recently was probing a little bit in the community of preservation and curation people what they think about that and if they would need that. And just on a it was a very limited sample here over the summer, but the response is very much positive in the sense of we really want that. And we have just organized a workshop at the Preservation Conference on Capability Assessment and Improvement, which draw a very diverse audience and discuss that. So the basic approach is that we want to design and evaluate and validate a well-grounded assessment model that essentially is something like a capability maturity model, if you're familiar with working in software engineering and other fields. Essentially, that's a design science research method applied using enterprise architecture frameworks, using situational method engineering for developing specific methods that we can put into place and compose to help people arrive at a common framework of assessing what they do across different organizational environments. Because clearly, when you assess preservation capability in an archive, you will use different language, you will assess different priorities than when you assess it in a library or in a data center. And then the third thing that I would like to talk about a bit is that this notion that longevity is not really a design concern that is addressed upfront when information systems are designed. There's lots of techniques on specific levels for improving the longevity of artifacts. For example, things like model-driven engineering, model-driven architecture that separate the code from the actual model from the code so that you can regenerate the software code. And the idea is that this increases the lifetime of the software. But the focus in reality is really on ex-post treatments. We all know of information that lies buried in information systems with hard ways to find an exit point. System lifecycle costs going very high, but at the same time the transitions costs being very high, and so on. So the thing is there is a lot of knowledge on aspects of this problem in different disparate disciplines, but little common view on how to integrate those viewpoints. So aspects are the fact, for example, that there's information longevity versus system longevity, which is really not the same thing. The information longevity, really the idea that the lifespan of each information object is essentially decoupled from the lifespan of the system in which it is managed. The question of systems resilience, but at the same time the systems also need to evolve over time, so they cannot stay static. Then the question of transition and exit points for taking something into the next system, and of course sustainability. So essentially, the goal here is to establish longevity as a concern that can be systematically addressed when you design systems by using methods from information systems design and software engineering, the insights from preservation and curation on the long-term effects of evolution and change and disruption, and perspectives of enterprise architecture on this holistic viewpoint of an information system with data, technology, people, and organizational aspects that has to be managed over time. Basically, essentially, a few of the things here is that we have been doing a systematic literature review, looking at the coverage of the different aspects of this, and founding a zero coverage on the exact overlap, actually. And the idea is to isolate the concern, to study it a bit more in detail from others, and to validate some of that also with studies of empirical software engineering data, which it will be quite a challenge, actually. And with that, I'd like to conclude. I have about 100 different slides that I would love to talk to. You know what?
Thank you very much. It was a very interesting talk. I am curious about is there anything to be learned from the stuff that went on with the Y2K? For what reason?
The non-problem?
Well, it was not a non-problem. I mean, it didn't have catastrophic results, but a lot of information systems had to be, like, a lot of data and system representation of that data had to be retrofitted to.
Well, what could certainly be learned, I guess, is studying if there is, and there was actually quite a bit of studies on the costs of that problem, studying what the effect of not considering this event were in fact in the long run. Because one of the things that happens over long term is that even very unlikely events actually become probable that they will occur. So things that were not foreseen. But of course the problem is how do you design for the unforeseen?
Right, but also there was a lot of work, so I know you're focusing more on going forward, but at the same time you have to think about what's out there already deployed, because not everyone's going to change, right? And there was a lot of work that was done, a lot of research and tools that were built that were able to go in and find the problem and
In the sense of diagnosis, you mean? Yeah.
diagnosis and
Yeah.
and pointers to how to repair.
Yeah, so the thing is, so I don't think there is something in the way of like there is a fundamentally new software engineering method that has to come out of this, or a fundamentally new way of designing information systems. Not at all. But longevity is a concern that has different impact. And the question is, what are the targets that you can set in different stages of a normal development project, for example? What are the possible design patterns? What are the indicators? How can you test? So, for example, if you look at a certain like an aspect like concern like security, what you have is that if you have really high requirements for security, what you might do is actually have to have verified modules of the software, and then what you can do, is isolating that concern into one design module, and then you use program verification on a very small module, and you try to minimize the area of design that has to be very expensive and very much verified. Now, if you think of longevity, how can you isolate longevity in an information system to a point where you can really verify that it's there in one point, and then can sort of better manage the different modularity and the different lifespans of the different modules in the system, for example. But the thing here is really that there is tons of research questions that are quite open here, and a lot of it is finding the right technique and putting it together in the right way, right? Bringing different communities together.
What happens to the hamster?
Once again?
What happens to the hamster?
Well, hopefully we will be able to free the hamster. And the question is, of course, the hamsters enjoy that as well, right? So maybe it will get a running band instead.
Put a generator.
Now, of course, yeah, the hamster is us, and we want to get out of the loop. Yes.
You referred to security a few times. Do people feel the same urgency in dealing with longevity as with security?
I think by the nature of the problem, no. But one thing that I find really interesting is that when I started working in conservation and curation 7 years ago, people would ask me, so what do you do? And I would say, oh, I work on digitization, and they would frown. What is that? And nowadays, the concern is really on everybody's mind, and everybody will know that say, oh, this is very important. And it has really made its way to all kinds of different venues, scholarly venues, IT magazines. It's a much bigger concern. But by the nature of the concern, it is easy to say, well, let's deal with it later, because of good and bad reasons. Of course, you can discount costs that appear in the future, but there are certain other cost curves on discovering a bug, an error in a system later, that show obviously that the costs would be very hard to fix. So it's a little difficult sometimes to make the case, and in some domains it's very easy to make the case, domains that have long-term management of system engineering, for example, civil engineering, and in other domains it's more an argument about life cycle costs and life cycle management, or security related.
Your idea of longevity is like, is it like a blanket that goes over everything, or you're thinking on selective longevity? So only for, do you apply some appraisal before saying, I keep everything for long?
So thanks for asking that. It's very good that you asked that, because I don't want to make the impression that all information systems should last forever. The point of, especially this information systems designed for longevity, is simply to have a better control in advance and a better way of handling the different levels of longevity. You will have certain time horizons in mind. Very often you don't want to keep things for long. And of course the appraisal and the selection are an important part of the information longevity of the objects in the lifecycle management, in the records management, and so on. So that's certainly not the idea, is to maximize longevity of everything forever, so that we have to keep everything and manage it over time, and we get more and more. That's definitely not the idea. So to make it more manageable, to make it more useful and valuable.